Hello! In this video, we're going to explore correlation measures. A correlation coefficient is a statistical measure that describes the strength and direction of a relationship between two variables. It answers, how strongly are two things related, and do they increase or decrease together? When comparing Pearson correlation and Spearman correlation, it's important to understand that they both measure the strength and the direction of a relationship, but they do so in different ways and under different conditions. Pearson correlation measures a linear relationship between two continuous variables. This means that it looks for straight line associations. Pearson assumes that the relationship is linear, the data is normally distributed, and both variables are continuous. Pearson's method is highly sensitive to outliers. A single extreme value can significantly distort the correlation. On the other hand, Spearman correlation measures a monotonic relationship between two variables. It doesn't require the relationship to be linear. It just needs a trend to consistently move in one direction, either increasing or decreasing. Spearman works by converting the data into ranks before calculating the correlation. This makes it much more resistant to outliers, suitable for ordinal data like rankings or ordered categories, and much more appropriate when the data is not normally distributed. Here are the formulas to calculate Pearson and Spearman correlation. Correlation coefficients always fall between -1 and +1. A positive correlation means that as one variable increases, the other tends to increase. A negative correlation means that as one variable increases, the other tends to decrease. Values closer to +1 or -1 indicate a strong relationship. Values closer to 0 indicate a weak or no relationship. Let's dive a little deeper into when it's appropriate to use Pearson's correlation. First, both of the variables you're comparing need to be continuous. This means that the variables should be able to take on a wide range of numerical values, not just categories or rankings. For example, variables like height, weight, temperature, and test scores are continuous because they can be measured along a scale and have decimal values. When your data is continuous, Pearson's correlation can help you understand whether those measurements tend to move together and how strongly they're related. Second, Pearson's correlation is designed to measure linear relationships. This means that as one variable increases, the other should either consistently increase or consistently decrease, and this pattern should form a straight line when graphed. If the relationship is curved, fluctuating, or nonlinear, Pearson's correlation might not give you an accurate picture. It's important to check that the data shows a clear straight line trend before applying this method. Finally, a normal distribution is recommended. A normal distribution means that the data follows a bell-shaped curve, where most values are clustered around the average with fewer extreme values on either side. Now, let's take a closer look at when it's best to use Spearman's correlation. First, Spearman's correlation is ideal when you're working with ordinal data, which means that data can be ranked or ordered, but the actual differences between ranks don't matter. For example, ranking students based on their performance, where we know who is first, second, or third, but not the exact score difference. Or organizing survey results based on how likely people are to agree with the statement. When your data is about positions or preferences rather than precise measurements, Spearman's is the right choice. Second, Spearman's correlation is also useful when the relationship between variables is monotonic but not necessarily linear. A monotonic relationship means that as one variable increases, the other consistently increases or decreases, but the pattern does not need to form a straight line. For example, more study time generally leads to higher exam scores, but the rate of improvement may slow down over time. Similarly, more exercise is generally linked to weight loss, but the relationship might not follow a perfect straight line trend. Third, when your dataset includes outliers, which are extreme values that can skew results, Spearman's correlation is a better choice. Unlike Pearson's correlation, which can be heavily influenced by outliers, Spearman's method is more resistant because it ranks the data rather than using the raw values. Fourth, Spearman's correlation is also appropriate when your data is not normally distributed. For example, in studies analyzing the relationship between air pollution and health, the data often does not follow a normal distribution. In such cases, Spearman's correlation gives more reliable results. Finally, Spearman's correlation is a great option for small datasets. Since it makes fewer assumptions about the data, it can produce meaningful results even when the sample size is limited. Thank you for watching! Understanding when to use Pearson or Spearman's correlation is crucial for correctly analyzing your data and making meaningful conclusions.